for method 2, you probably won't go through all of method 2 here, but for method 2 on this one, if I look at this problem and keep it completely as it is, then what I've got to think about, well, I could do this. I could make it 1/2 x, the quantity x minus 1 to the 1/2 power. That might help out some. But I still see that I've got, let's say we've got a product. So I have to use the product rule. Whoops, I forgot something, didn't I? Something major. Let's start over again on this. Forgot to put in the log piece of it. So log base 3 of 1/2 x, x minus 1 to the 1/2 power. Okay, so I do see a product in here, 1/2 x, but if I work this the way I'm supposed to, I would have 1 divided by 1/2 x, x minus 1 to the 1/2 power. That's how we start. Okay, it's always going to be that way. Times 1 divided by the natural log of the base times the derivative with respect to x of 1/2 x, the quantity x minus 1 to the 1/2 power. Now, it's up to you how you'd rather work this. If you didn't think of breaking that log statement apart, then this is what you would have to do. Here, you've got a product rule to take a look at. And once you write out the product rule, you're going to have a composite function, so you have the chain rule to use. It's not impossible to do it this way. It all depends on how you want to start it. Okay, so I'm not going to finish this. I'd rather go on to a different problem because we've already talked about what we need to on here. Okay, now there was one problem that we skipped, and I said we'd come back to it, and it's this one. This is earlier in your notes. So if you go back in your notes about 5 or 6 slides. And the reason I skipped it on Tuesday was because there is no composite function in here. However, there is some information that we need in order to work some of the other problems, and we're ready for those now. So we're going to take a look at these now. Okay, it says find the derivative. So part A is to find the derivative. So let's take care of that right away. We have the derivative with respect to x. Now when we come back Thursday, a week from today, I'm going to have a quiz for you on sections 3.2 and 3.3 that will involve the quotient rule. So just, I don't want to have you stress out, but I think you guys are ready for that now. I don't think you have to work too hard to get ready for that quiz. But 3.3 and 3.2 and 3.3. So let's just do a little review. I want to make sure you understand what work I want you to show me. I talked about it on the videos for last week, but let's go over it in person here. So on a quotient, we take the denominator times the derivative with respect to x of the numerator. In fact, I'm going to write this as x to the 1/2. I'm going to get ready to look at the derivative of that. Remember that we are in a quotient, therefore we subtract, and then it's the numerator times the derivative with respect to x of the denominator. Everything divided by the square of the denominator. This is the first step. This is the work I want to see. This is showing me the derivatives you intend to take. This is demonstrating your understanding then of the quotient rule. Okay, so the first step is showing me the steps or the derivatives. Second one is actually to take the derivatives, and of course with the chain rule sometimes you've got more than one step of showing me derivatives. You can't always do it all in one step. So we have now x squared plus 1 times, and now I just need the derivative of x to the 1/2. You don't have to show me any steps for that. You can just write it out, 1/2 x to the negative 1/2, and then of course the 1 would be 0, minus the quantity x to the 1/2 plus 1, and the derivative of x squared plus 1 would be 2x. All of it divided by the square of x squared plus 1. So you show me the derivatives you plan to take, and then you take the derivatives, and then of course you're going to actually do, try and do at least 2 steps of algebra. So if we do that, let's see, we'd have 1/2 x to the 3/2 plus 1/2 x to the negative 1/2, and work the negatives carefully. I've got here 2x to the 3/2 minus 2x, all of it divided by x squared plus 1, quantity squared. We've got some x to the 3/2 we can collect. Here again, I'm not going to go through all the algebra with you. It comes down to, one answer would be negative 3x squared minus 4x to the 3/2 power plus 1 divided by 2 square root x, the quantity x squared plus 1, quantity squared. And you might think, well, how did this get in there when I just have these 4 terms? You've got the negative 1/2 here. That makes then, if you make that a positive, that makes this term only 1 divided by 2 x to the 1/2. So you've got a fraction in the numerator, you'd have to find a common denominator, and et cetera, et cetera, et cetera. Okay, that isn't the most important thing I want to talk to you about, though. Let's go back. It says graph the function and the derivative on the same set of axes and describe the behavior of both. That corresponds to zeros of the derivative. This is the piece that I really want to spend some time with you on. The algebra to get from here to here is up to you. You guys know algebra well enough, you can do that. Okay, so let's do this. Let's graph both of these. Take your inspires. And go to a new document. Let's start fresh. And go to a graph page. And let's very carefully put in what this would be. We need a fraction here, and so forth. Now to get the entry line back, if it goes away like mine did, just press tab. And then, now, before you put in that derivative, I'm going to talk to you just a minute about that. So you have the function in, everyone getting that? Pardon? The original function? Okay, that's what we're putting in as the original function. I'm going to pick that quantity up. I'm going to move that up there. Okay. Now, in order to find the derivative, or to graph the derivative, we could go back and type in everything we had. Now, that's part of the problem. Would be for me, if I ask this, would be to see, do you know the quotient rule? That's part of it. But the other part is, in order to graph this, we would need to put in something like this, or we could use our algebra here. Find the symbols palette. Now on this model, it's right here beside the 9 key. On this model, do control multiplication. and you've got a derivative template. So let's find the derivative template. And we're going to, the function 2 is going to be the derivative with respect to, what's our input variable? X. Okay, tab over. And now you want to take the derivative of what function? Yeah, so just type in f1 of x. This is an easy way of doing this so that we don't, we can still get part of the answer right even if we might have made a mistake on the algebra. Hopefully you didn't, and of course you checked it before you moved away from that question, but you don't need to go back and retype it. But we end up with this. Now I'm going to change the window settings, and I'm going to put in -1/2 and go up to 5 and scale by 1. And then on the output, -1 to 2, and I'll scale by 1. So I'm going to use that window. And that gives me a little better view of it. Now, again, if you didn't do it before, separate those labels. Okay, you go back and check, Daniel. Did you put in f1 of x as it should have been? And for f of 2, did you have parentheses placed the way they should have been? Okay. Now the other thing I'm going to do here, I'm going to change the looks of one of these so I can kind of see it better. So I'm going to go to Menu, Actions, and Attributes, and I'm going to point to the graph, and I'm going to make that just a shade bolder than the other one, just so I can see the difference between them. Danielle, did you get it yet? Okay. Let me take a look here and see if I can help some of you out if you're not where you need to be. Okay, some of you are still getting the window. Okay. Yeah, something happened over here. Let me take a look at this person's work. What happened to your, did you press enter? I didn't see who this was. Let's take a peek here. Brian, right here. Did you, is it worked out now?
Yeah, it just takes a while to figure it out.
Yeah, mine's been a little bit delayed.
A little delay? Okay.
Yeah.
We won't worry about that then. Okay. Okay, so everyone is looking pretty good then. Daniel, did you get yours figured out? Okay, good. And again, if you want to change the attributes on that, do so. Peter, I see you haven't got the second one there yet. Is it coming? Loading. Okay, I don't know why things are taking longer, but it's okay. I'll continue on, and I see everyone's up with me. At least you know what you're supposed to be looking at. Okay, so now the problem said to describe the behavior of the functions that correspond to the zeros of the derivative. So again, my derivative is this lower curve. And if I want the zeros of the derivative, where am I going to look on the graph for the zero of this derivative? Well, the zero of any function says you look for where the, go ahead, Megan. I saw you forming the answer there. The zero of any function is where, is the point you look at is where the zero of the function. What? Okay, where the graph crosses what? Which one? We have two axes on a coordinate plane. I don't want to hear x. I want to hear another word. Okay, or the input axis. Okay, you're going to see a problem where x is actually the output variable. That's why I'm trying to get you away from that.